Finally, we're going to compute the relative profitability of products in bottleneck process. So a production bottleneck, this is the point where the demand for the product exceeds our ability to produce it. So we look at that hourglass, so that the middle of the hourglass that filters the sand, that's the bottleneck where it stops the flow. So there's an idea called the theory of constraints, where we look at reducing bottlenecks in a process, reducing that point where you look at the hourglass where the sand stops flowing smoothly. You look at points in a process where that happens, where things slow down. So if you look at go back to our birdhouse company we've been talking about, you know, the people that cut the wood, they're moving real fast. They're doing great. The people who nail the boards together, they're doing great. But there's a big holdup in the painting department where things bottleneck up. It goes slow. The idea would be look at that painting department, find ways to make the process better so it can go faster, so we can get the birdhouses through the process more efficiently and faster. So we can look at a bottleneck. So we can look at the contribution margin per unit. So we can see the large wrench is the most profitable. $120 contribution margin versus 90 for the small and 100 for the medium. But that's not the whole thing though. See, the contribution margin per unit suggests that the small wrench is the most profitable. Because if we look at it by hour that they're spent on that heating process, you could get small wrenches through the process faster. They're only using 1 hour in that bottleneck process, where it takes 8 hours with the large wrench. So if you take the unit contribution margin divided by the bottleneck hours at that bottleneck in the process, some might tell you that the most profitable is the small wrench because it spends less time being bottlenecked in the process, where the large wrench bottlenecks the process. So product pricing for there's a lot of math you can go that goes into this, and if you take a higher up cost accounting course, you get more into this. But we assume that the variable cost per unit and the heat treatment hours for the large wrench can't be decreased. We're assuming that we can't make it any better. So we have to, let's see, what would we have to price the large wrench to be to make it as profitable as the small wrench when factoring in the bottleneck? So what we'd have to do is take the revised price of the large wrench minus the unit variable cost for the large wrench divided by the bottleneck hours per unit for the large wrench.